So, nasa part na tayo ng pattern and arithmetic sequence natin. So, we will focus on how do we derive the arithmetic formula, the general formula, and some examples related to general formula and arithmetic sequence. So, let's dive in. So how do we derive the arithmetic formula? So let's try right here. Okay. So arithmetic formula looks like this. Last term is equal to a plus a first term plus number of term minus 1 times d. So paano natin nakuha yan? So we should know na first term is equal to the last term if we only have one term. So if we have like this 2, our first term and last term are the same. Okay, but if we have two term, we will add the common difference. So if we have let's say 2 and 4, we have two term. This is the first term, this is the last term. So an is derived by adding the first term and the common difference, which is based on here 2, diba? So what if we have three terms like this, 2, 4, 6? So in this type of we have three terms. So three terms, same process. Last term is equal to, we just copy this second, we just copy this two term formula, and we add its value to common difference. And if we combine d and d, we will get a1 plus 2d. Now, since we have three terms, an is a3. Same as here. If we have two terms, we have a2. So we say na first term is equal to the last term if the term is only one, because a1 will equate to a sub 1 also. So this will continue until such time that, so let's try for term. So 2, 4, 6, 8. a4 will equal to a1 plus a plus 2d plus d. Combine the terms, we have first term plus 3d. So we notice that if the term is 4, we multiply the common difference by 3. Okay, in this term, in this pattern or general formula, if our number of term is 3, we multiply the common difference by 2. So any number that is multiplied to common difference, we will just add 1 in order to identify the number of term. So our formula will looks like this. So as I was saying, we will subtract 1 from our number of term in order to get the multiplier of our common difference. So our formula will be an is equal to copy, and as I said, we will multiply 1 to the number of terms to get the multiples of the common difference. So it will look like this. This minus. So this is, these are the same. So let's try and solve some arithmetic sequence that does look like this. Okay, so our in order to solve this, we must first notice that our first term is 5. So first term. Okay, second term, third term, this is our fourth term, fifth term, sixth term, and seventh term. Okay, so if you're given this and we need to identify these three what do you call this, these three gaps. Okay, we need to first find the general formula of this specific pattern. So how do we find it? So let's say that is to have en is equal to first term plus n minus 1 times t. Okay, we'll leave the last term because our n this. Okay, we should find this. Okay, so we leave this at we'll leave this as it is. Okay, because we are out to find our numbers terms. So a1, so what is our first term? That is 5 plus this, bring down n minus 1 times d. So our common difference is can be obtained by subtracting this second term and first term. So we have 16 minus 5, that is 11. Okay, so what do we do next? So we will times 11 to this parentheses, since we can't subtract n from 1 because n is a variable and 1 is a number. Okay, so we will distribute 11 to this n and negative 1. So 5 plus 11 times n is 11n, and 11 times negative 1 is negative 11. Then we will combine like terms. So copy 11n and combine positive 5 to negative 11. So we will have negative 6. So this is our formula, general formula for this pattern. Now, how do we use it? So our first term is 5. Okay, so if our first term is 5, our n is 1 because this 5 is at the first term, diba? So let's try and find if the last term will correspond to first term by using this general formula. So an is equal to 11n minus 6. Our n is 1 since it is at the first term, minus 6. 11 times 1 is 11, minus 6, that is 5. So our a1 is 5. So let's try it on our second term. So we must find a2. 11 times n, which is 2, since we are out to find second term. minus 6. Okay, so 11 times 2 is 22 minus 6, and 22 minus 6 is indeed 16, and this is true because our second term is 16. So now that we know that our general formula is valid, we'll try and find the fourth term. So our third term will look like this. A4 is equal to, again, 11n, where n is 4, since we need to find the a sub 4, or the fourth term, minus our constant value, which is 6. So 11 times 4 is 44, minus 6. So that is 38. So our third value is 38. Now, what is our fifth term? Okay, so again, fifth term, a sub 5 minus, equals to 11 times our number of term, which is 5, minus constant value of 6. 11 times 5 is 55, minus 6. That will yield to a sub 5 is equal to 49. This is 49. So to find our seventh term, same process. A sub 7 is equal to 11 times, again, number of terms, 7, minus constant value of 6. 11 times 7 is 77, minus 6. So that is 71. So our a sub 7 is 71. So that is how general formula works. Okay. Now, let's try and find the general term for this type of question. So just the ano lang, general term lang, no other thing to derive. Okay, so we'll use the arithmetic formula again. Okay, so this is an is equal to first term plus n minus 1 times d, or an, again, we'll leave it like this, is equal to first term, which is 9, plus n minus 1, and our common difference, we need to find it. So in order to find it, subtract from second term to the first term. So 12 minus 9 will equate to 3. So an is equal to a1, bring down, plus. So again, we can subtract it, so distribute 3. So this become 3n. Oh, this is 9 pala. Ba't ka nakalagay ng 1? So 3n, again, 3 times negative 1, that is negative 3. Combine like terms, 9 plus negative 3, that is 6. Bring down 3. So this is our general term for our specific pattern. This.